All right, so today we're talking about diatomic atoms. This first part is a little straightforward, so I'm just going to read it to you. It says there are a few atoms on the periodic table that are never found alone. They always need a buddy. There are no other elements available. They will form bonds with atoms of the same element to attain an octet. So the similarity here is that the hydrogen just needs one more electron in order to fill up its outer shell. So when a hydrogen and a hydrogen become buddies, they form a covalent bond, and they're sharing that electron there in the middle, and they form this HH bond. So we would write that H2. Okay, so let's go ahead and add a little to our notes so that we can make sense of this. So chemical reaction 6. I can't see my fingers. Diatomic atoms. All right. So just like we have seen before, di is 2, like dioxide. So this means these are atoms that form bonds with the same element. That'll make more sense as we take some notes. So we have that example there of hydrogen forming that covalent bond. Let's go ahead and take note of that. We have a hydrogen Lewis structure and another hydrogen Lewis structure. That's going to yield hydrogen sharing those electrons. So now the electrons have a buddy, the atoms then have a buddy, and we would get H2. Okay. So hydrogen is a diatomic atom. So we could note that. Okay. All right, let's look at this next example, chlorine. We have the same concept here. We have chlorine with its Lewis structure. We see each chlorine atom has just one lonely electron. So if these guys can become buddies, then we form a covalent bond, and we get chlorine 2, Cl2. So we'll go ahead and draw that in our notebook so that we have those notes for our posterity later on. But I'm gonna go ahead and encircle these lonely electrons here. We're gonna get chlorine, and then that second chlorine. Now there's 8 electrons around each of the chlorine atoms, and so we get Cl2. Okay. If we look at this Lewis structure, are there other elements that would fit in that same Lewis structure configuration? So a better question, what other elements have a Lewis structure that have 7 electrons in their valence shell? Let's bring in our favorite periodic table here. We know that all of the elements here in group 7, in the halogen group, are going to have that same Lewis structure. So we know that all of these elements are diatomic as well. So we could have fluorine, F2, chlorine, Cl2, bromine, and iodine. All right. Let's make note of that. So we might have, like we said, fluorine is never going to be by itself. Chlorine is never going to be by itself. All of the diatomic atoms need to have that buddy. So we could draw the same structure for all of these guys. Okay. Let's go back to our lesson and look. But then we have this example here of oxygen. Why does oxygen work? We look and we notice the oxygen's Lewis structure. It has 2 lonely electrons. But these 2 could make buddies and form a double bond between oxygen. And that's where we get the oxygen gas. So we'll go ahead and make note of that. And I'm going to go ahead and draw the Lewis structure for those oxygen atoms, just so that we can note this is the same thing we've done time and time again. We have filled up the outer shell by pairing up the lonely electrons. It's just that in this case, we are going to use the same kind of element. It'll be the same atom. So we're going to get O2. Okay, still filling up those octets around there. Nitrogen is the same. Nitrogen is never going to be found alone. Nitrogen will always have a buddy. And since there's never going to be one atom of nitrogen just sitting there, these diatomic atoms will bond with another atom of the same element. And we can just kind of draw those bonds. Nitrogen makes a triple bond. Oxygen makes that double bond. So I'm going to take my camera away for a second and let's look at our list. Hydrogen, nitrogen, oxygen, fluorine, chlorine, and let me... we can see all of them at one time. All right, and bromine, we have the 7 list here. So if we look at the periodic table that you have in your lesson, I want you to make note of all of these. Hydrogen is diatomic, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. 1, 2, 3, 4, 5, 6, 7. So I'm going to go ahead and put that in my notes as saying they're diatomic 7. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. You're going to need to memorize these because when you see them in word problems, it's going to be important that you know there's 2 atoms there for balancing, for writing the equation, for stoichiometry in the next unit. I have a mnemonic device. It's not very nice, but it is one that people use for you to remember the letters, the abbreviations. I have no bright or clever friends. It's not very nice, is it? But iodine, hydrogen, nitrogen, bromine, oxygen, chlorine, and fluorine. Those are going to be the ones that you need to know without a shadow of a doubt. Okay? In the lesson, you are given these polyatomics, which are phosphorus and sulfur. I'm never going to give you a problem that has any of those in it. But you might, if you go further in chemistry, it's important that you realize phosphorus never exists by itself. And if it is just by itself, then it would be P4. It'll form this pyramidal shape. Sulfur exists as sulfur 8 in this kind of shape. So it's pretty important that you remember that. And these things do exist. We can go over and get both of them as polyatomic molecules. Okay. So give me a thumbs up if that makes sense to you. Like, it's really just using those covalent bonds, but does that make sense? Thumbs up. Okay. All right. So let's go into the practice. I'm going to stop that recording for right now.